In our final section here, we are looking at solving problems with similar triangles. So if we knew how to check for triangle similarity, now if we're told yes they are similar, we know that sides must be proportional. So we're going to just create proportions, except now we have to solve them because we're going to have an unknown side. Let's do that. In these problems, we're going to rely on our pictures a little bit. In general, in geometry, that's a little bit of a dangerous thing to do because a picture and a diagram are different. These are diagrams. We don't actually know what it's supposed to look like, but we're going to trust that the one that looks shorter is shorter. That's the best we can do in these problems. So we have a 25 and a 15 that appear to be from the shorter side that we are given. We have these angles the same. And then we have the longer side, the question mark, or 35. We're going to call that x because question marks get a little bit weird in algebra problems. So we need to create the proportion, and I'm going to do this as top over bottom. That's what we've been doing. And when I do that, I have an x from this triangle of the purple and a 35 over here. So x over 35 equals, and then we're going to do the red one, 15 over 25. 15 over 25. The thing that you're probably most familiar hearing when you do proportions like this, something over something equals something over something, is cross multiply and divide. I don't like those terms for a number of different reasons. They tend to cause problems when you're dealing with fractions, and a lot of you tend to not be big fans of fractions, probably because of things like that. However, if you feel very comfortable with that and know what to do, you can go ahead and do that. If not, what I'm going to recommend is clearing these fractions by multiplying both sides by both denominators. So what that means in this first problem is we multiply both sides by 35 on top, and we multiply both sides by 25 on top. And then we look to see if anything can clear from top to bottom, can divide out to 1. And in this first fraction, we have a 35 and a 35. 35 on top, 35 on bottom. Those will reduce down to 1, go away. We have a 25 and a 25, top to bottom, that are all being multiplied here, so they can reduce down to 1. And that leaves us on top with 25 times x on the left. And 15 times 35, let's do that in our calculator. And we get 525. If we want to get x alone, we're going to divide both sides by the thing that x is being multiplied by, which in this case is 25. So 525 divided by 25 is going to be 21, I believe. Yes, 21. So x equals 21. The reason this worked is we knew that we had similar triangles, so we knew we could create a proportion. Our proportion had a missing thing, x, a variable in it. When we worked through the problem of then just solving the algebra, we got the missing side. So that would go right there. And if you look at the picture, 25 to 35 goes up a little bit. 15 to 21 goes up a little bit. It does make general sense. It's always good to plug this back in over here and look at the picture and say, does this kind of fit? Because usually when you make a mistake in problems like this, you're going to get something that's really in the wrong direction. So you might have got something like 9, and then you know you definitely did it wrong if you got that. So that's a good way to check it. Let's go ahead and jump down to one of the problems down here that looks a little bit different. In these problems, we have these butterflies, I like to call them. And when you have a shape like this, you are going to end up having these angles that are across from each other end up being the same. So because of that, you know that you're on your way towards similarity. It also just tells you that the triangles are similar, so you wouldn't even necessarily need to know that. From looking at the picture, it is not actually possible to tell if this is matching up with this one here or with this one here. So I'm going to just let you know that you can assume that the two that appear longer are going to be the longer ones. So those two match up with each other in the same way that these two match up with each other. So we're going to call this left triangle, and we're going to call this the right triangle. It's not a right triangle in that it has a right angle, it's just on the right half of the page. So we're going to do left over right this time. We've been doing a lot of top over bottom. We're going to do left over right. And for the reds, I have the left one has a 370, the right one has a 100. For the pinks, the left one has a 629, the right one has a, 7x minus 47. That's crazy. I'm actually going to replace this big mess here with a new variable. This is something you'll see in math a lot, and it's called substitution. It's a way of not dealing with messy things like that. So let's just call it U. U is a common letter for substituting. This will just make life easy. Now we have our problem here, and we need to get rid of our fraction so that we can start solving this thing. I'm going to multiply both sides by the things I see in the denominator. So I'm going to multiply both sides by 100, because I have 100 in one of my denominators. I'm also going to multiply both sides by u, because I have a u in both denominators. When I do that, the 100 and the 100 are going to reduce out. The u and the u are going to reduce out, leaving me on the left side of the equation, u times 370, or 370u. And on the right side, 629 times 100. So 62900. I want to get u alone. Don't take that the wrong way. Divide both sides by 370 to do that. And when I take 62900 divided by 370, I get 170. That's a good calculator one there. 170 is equal to u. That is not the answer, though. That's not x. That's u. It means that this thing right here is equal to 170. So if I want to find x, let's just take that thing and make it equal to 170. So when you do substitution, it's kind of like a temporary thing to give you easier numbers initially, and then you bring back what you took out at the end, so that you can just kind of do it two smaller problems instead of one big messy algebra monster mess. And that's what we're doing. So we're bringing this back. Now to get x alone, we have to get rid of everything else on that side that's being added or subtracted first. We're going in reverse PEMDAS order. So we need to add 47 to both sides. And when we do that, the right side becomes 217. You add that up. The left side, 47 and negative 47, add up to 0, so those go away for us, and we're left with 7x. And then finally, our last step is to divide both sides by 7, since x is multiplied by 7. And when we do that, we get 31. This is equal to 31. And that would be our solution for that one. So as you work through problems like this, again, use the picture to treat it more like a picture than a diagram, in that you assume the long things match up with the long things, the shorter with the shorter. And on these butterfly type problems, we're going to say that for the most part, it's the ones that form an angle with each other. I think on this problem, it will likely be that this piece is similar to this one, or proportional with this one, and this one here is similar with this one. If you get some really weird fractional answers, that might be switched. Some of these pictures are not very good for problems like this, so don't get too hung up on an example like that. And if you're not sure, just make sure you ask.